The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. Welcome to our webinar. Today, our webinar topic is drawing production using OrthoGen. Our panelist today is Joel Holmes, a director with 3DS. Joel has more than 30 years of industry experience in CAD and plant design and focuses on providing tools that optimize 3D project execution workflows. Joel is the creator and product owner of OrthoGen and provides product development direction for OrthoGen. A quick reminder before we start, all attendees are muted by default, so if you have any questions or comments, please type them into the questions tab. And with that, I would like to invite our panelist. Joel, over to you.
Okay, let me show my screen. Start off good morning, everybody. Thanks you for joining us. Know everybody's busy these days. We're going to try to go through three aspects of OrthoGen today: design, fabrication, and construction. And I believe the point is that whether you're a design-only firm or design build or a fab shop, there's something in OrthoGen for all of you, and we'll show you the different ways you can use it. We're 3DS Net Inc. We're based here right outside of Houston. We created OrthoGen 21 years ago. Been developing it ever since. We support all three of the Intergraph platforms, the PDS, Smart Plant, and CADWorx. Our new OrthoGen 10 supports CADWorx and Smart Plant. And a distinction about OrthoGen and the way it works is it operates on entire viewports in a single operation. It's not a touch and drop one label at a time. It's not a manual dimensioning, although on some drawing types you will want to add some manual dimensions. Currently annotates the entire viewport, like I said, in a single operation. We work on the standard viewports in 2D layouts in AutoCAD. You pick a drawing style. I'll show you the drawing style editor and such. You hit the process button, and in seconds it will add all this annotation. A lot of different filtering options. You can have it place a label on a pipeline for only one label for every unique pipeline, or for every direction change, pipes coming out of the screen. We'll go through some of that. A lot of different options. In this latest release, we've added a new module called the View Manager or Space Manager. We're able to create clip views and annotate them in 2D layout or in the 3D model space. We've got a product for PDS and S3D called iOrthoGen, where the users, they use it in the fab shops and in the yards for construction support. Field engineers are able to clip any volume of the plant, look at it from any direction, and add dimensions and annotations to it. So basically it's on-demand GA drawings at a module shop or a yard. I'll show you some of the View Manager today. OrthoGen 10, the new interface. Talk a little bit about the workflow. We've got special operations that place labels interior in the view. Instrument tags, equipment numbers, and such. It's going to search out. You have the option to have it search for a clear space for the label. It'll always want to probably, on a busy drawing, do some rearrangement for clarity. You'll have some leaders that cross and whatnot, but once you get them straightened up, as you do your updates, OrthoGen will update those tags in case they've been changed in the model, and will hold the location that you put them in. So you don't have to do your embellishment work more than once. There's different kind of level of detail, I guess we'd call it. General location drawings will typically put the tags interior, like for equipment or piping, equipment numbers, instrument tags. Then we can do the locations around the outside of the view, or exterior. And on a general location drawing, all of this can be updated by OrthoGen. It means it will wipe out the existing labels and completely redraw it every time. But any of the interior tags that were relocated, it will remember those new locations. On a detailed location drawing, something like a steel drawing, you're going to want to put your tags interior. You might do the dimensioning around the exterior one time, but the user is going to break and take over the dimensioning and do those manually. On a complicated steel drawing, you can't just automatically place labels around all four sides of the views. It's still a skill involved in dimensioning those drawings. Now, OrthoGen, again, in case of steel drawings, can update all the tags, the section marks and the offset dimensions and so forth. So it's a combination of very automated on the interior labels, completely automated, in fact, but on more detailed drawings, you might have to go into a semi-automated mode on dimensioning. OrthoGen 10 is a new modern interface. It runs in multi-languages. We've got a brand new style editor module where you can define what is to be labeled on your drawing and how you want it to label, inside, outside, coordinates, dimensions, and so forth. We also deliver about 30 plus styles, maybe 40 nowadays. Different styles for each discipline that can be copied and customized real quickly. And the whole thing just rolls up. It's an extensive collection of annotation dimensioning options, all available, and it's easy to use, no programming required environment. Very, very easy to use, very easy to implement. You don't have to do any programming and so forth. There's a look at the OrthoGen interface. The top section here is where you'd pick your drawing files. This next section, the refresh data, is whether you want to re-extract the data from the DWGs or not. If you're doing customization work, maybe you don't want to re-extract the data every time, although it's extremely fast. We extract all the data from the X data and the attached models. The existing labels you can update, which means wipe them out and redraw them, or you can append them and apply more than one style to a single view. Annotation Z is when you start working in the model space in 3D. We can draw labels in 2D, which would be a layout. In the true Z, which would be it would actually stick to the ends of the pipes. Low Z or high Z clip plane of a volume, view volume. I'll demonstrate some of that. The next group is the view style. You have a discipline and then a drawing type interface. We deliver, like I say, close to 40 styles. Once you pick a style, then it's summed up in this active settings group. It'll tell you your project name, your units. I'm labeling grids, equipment inside, clear space, instruments inside. So it gives you a really good roll-up of what this style is going to do without having to go in and review the detailed settings of the styles. So it's really easy. You can annotate drawings much faster before this. OrthoGen 10, it actually connects with AutoCAD and instantly updates the drawing when you hit the big blue arrow there. The style editor, here's a look. We present you a list of the entities that we allow to be annotated on the left. You pick an entity and you have 4 tabs where you can define the annotation options, whether it's inside, outside. If it's an exterior label, you can tell it what type of exterior, a 3-point leader, a coordinate label, or a dimension. The line options tab lets you control the offsets of exterior labels, how far they offset outside the view boundary. The text options is where you define your CAD settings for your text, your layer, your sizes, fonts, and so forth. Also on here we've got our layer for our entity that we're going to annotate and its symbology, color, weight, style, the name of the arrowhead to be used, center line symbology. We draw the center lines of the pipes automatically. So you can access all these through the style editor. You can copy styles, modify styles very quickly. Yeah, all the different things you control. What's going to be labeled, how it's going to be labeled, whether it's inside or outside, and then all of your CAD parameters for that label. Under design, we're going to cover design, fabrication and construction usage, general arrangement drawings. This is a document where we're going to generate the identifications and locations for the primary objects for the drawing type, equipment, piping, so forth. On a medium to large project that requires deliverables, you could spend 10 to 20% of the project cost on these deliverables if you've got a lot of drawings. So there's a area of substantial savings here. We'll talk about that some more. The general arrangement drawings support the installation of the pipe or the equipment, identifies everything, locating them for all disciplines. Use this in addition to the of a model, viewer, and ISOs. It's not an either-or situation. It's a very extremely good complement to a 3D model and a set of ISOs. Very important for planning. Very important for planning. When you're looking at scaffolding to install pipe in the rack, you don't want to work off ISOs and be looking at it one line at a time. You want to be able to put up a scaffold one time and put all the pipes, that sort of thing. So it saves a lot of time working out spacing distances for pipes in structure where you don't have to try to figure it out from each pipeline's individual ISOs, or haphazardly take measurements in a model. You really don't want to take those measurements out of the model. It's too easy to make a mistake. Another aspect is not all drawings are deliverables. A lot of design, planning, estimating, spacing, rack loading, just general characteristics of your unit, your bottom of pipes, top of steels. You can get good model drawings that will show you good status, progress of the model. It reflects immediately the condition of the model. Are all the line numbers filled in? Are all the instruments tagged? There's no hiding it. It's going to come out. So it guarantees your model integrity and that you're not just looking at a nice picture, that you've got solid data. Nothing brings it out faster than an automated ortho. Generate drawings for checking your layout, spacing, access. You do all these things with the models too, but it's a lot easier in some cases to just take a drawing and study it. We make a lot of system drawings for stress, process, and especially for installation contractors. So not all drawings are deliverables. They can be used to accomplish a lot of different tasks. In the design segment, we're also going to talk about the OrthoGen View Manager. This is it's designed to replace the view box command. We're going to be able to go into model space, interactively define a volume and a looking direction. We can add annotations in model space to make 3D details. I'll show you some examples of those. The real power is we can create the viewports from the current clipping defined and put them on a layout immediately. So we can really crank out these viewports really fast. The rendering on these drawings, AutoCAD users have been rendering drawings for a long time. It makes the drawings much easier to understand than a traditional line drawing in some cases, especially complicated drawings, especially if you're viewing the drawings on tablets. It's just a lot easier to interpret a rendered view than a traditional hidden line removed view. Here's a screenshot of the View Manager. We load our form. It shows us our current orientation and scale, our current clipping. We can key in volumes in this clip. We can take, we've got key plans here that we can just window volumes in the plan and in the north. Once you've got a volume defined, you can use these sliders to just step it along. You can step down the rack, step and save, create your rack plans. And you can see that 3D annotations out here. So we've clipped this tower out of this sample project and added some line numbers to it here in model space. This view here can be printed to a 3D DWX and distributed here. These are planning documents that can be very, very powerful, especially if they're cut in critical spots. This is an example of a piping plan with full rendered mode. Again, a very good example of a document that's going to be much easier to read on a tablet versus the traditional line drawing stuff. Really, there's no confusion which is the pipe and which is the spaces between the pipes when you got parallel pipes. I'd like to point out that looking at that 3D, we're saying drawings are not flat anymore. We can make 3D PDFs, DWFXs. We can publish these 3D files with the annotations. You can cut a view that looks just like a traditional view, a plan view of an area, but all the labels are actually in 3D space, and you publish the 3D geometry for that drawing view. We don't like to say that we're annotating a drawing, but we're creating a drawing that contains the model geometry. And that is going to be the best thing to ever happen to somebody who may struggle to visualize 3D from 2D documents. And I'll show you how that works here in just a minute. So here's like an isometric view of a 3D PDF of a tall tower, and we've had it tag all the pipe supports. I'll demonstrate this in a minute, but we can adjust the clipping, we can rotate this, we can turn on the support tags, the instrument tags, the pipeline numbers, the small equipment. I think there's 3 or 4 different items tagged in this thing, and it's all available for planning and such. Underground piping, I've got all my catch basins, all my line numbers. You look at it from the top view, it looks like a traditional plan drawing, but you can, if 3D PDF, you can rotate it up, use the clipping planes, and get a lot more out of it than you can just a traditional old plan view. This is a good example here. It's a piping GA, looking at it from the top. Colors could have been a lot better, but it was a function we were after. So we got all the line numbers all labeled. We got the instruments tagged on the inside, equipment labeled. Column grids are all automatic. But you look at it from the top in the 3D PDF viewer, then you can rotate it around, and you can see that it's not just a drawing. You see we've manipulated our clipping plane. We can push that clipping plane right through this model to really inspect what's going on. So it's a drawing that contains geometry. Work packages. Most of the yards, they like to include a work package, a GA, dimensioned tag GA, as part of the work package. It just shows how everything goes together. It's an invaluable tool for the field engineers. All right, so we're going to demo a 2D layout. Okay, now we've switched over to CADWorx model, what we call a master model. This model, we've got all the models that we want attached to it in as XREFs in the model space. We've applied an X-clip to these models, so we're looking at a small clipped portion of the ICAS sample model. Before we start annotating, do a little basic cover from some OrthoGen basics. Project settings. A project form allows you to create and name your own projects. For any project, you can define the 3D modeling system, the version of AutoCAD, and where you want to store your view styles for the project. Default styles are stored in Program Data 3ds.net OrthoGen view styles. You also define your distance units and your diameter units. The projects are kept in a project file, and it's stored in the Program Data 3ds.net OrthoGen folder. All projects are kept in the project file. So next, I'd like to cover some OrthoGen basics. We're over in a layout now. We've got a viewport. The viewport has had CADWorx 2D Rep run against it, which outputs this vector graphics we call VHL graphics. Even if you don't want to use the VHL graphics in your final plot, it helps OrthoGen a lot. We use the VHL graphics to search out the clear spaces for the labels. So we're going to add some basic labels, some tagging. We're going to use equipment for the example. We'll just double click and bring up the view editor. View Style Editor, and we'll tell it that we want some equipment labels on the inside or interior. Just place the name and find a clear space for those labels. So once we select that one entity, we accept it. You can see it places all the labels, searches out a clear area for them. But also we had a report block placed in here, E-bomb, a block that marks the insert point for this report. You can see we've got a report of all the equipment on this view. So that's basic for all tagging operations. You can search out a clear space, or you can place it with a fixed offset, go over ½ an inch and up ½ an inch and so forth. So next we get into locations. In order to do proper locations, we have to have dimensions to grids. So we have implemented in OrthoGen the use of a grid model. This is just another CADWorx model. We've drawn the line work for the grids and place a piece of text on the ends of the grids, grid lines, or in the middle, just on the line somewhere. Now, these will never be plotted. They're just used to generate the labels in the OrthoGen. So if we go back to our layout, back to our style editor, and tell it that we want to go to the grid entity, we want grids, and we do not want a coordinate label, or we do. And then we're going to go to equipment and switch it from interior to exterior. Accept that, and then when we generate that, you can see now that it's generated labels for the grids and for the equipment. Each piece of equipment's identified and located in 2 directions, located to the nearest grid or nearest equipment items. And again, we've got our report filled out. Now these dimensions are again OrthoGen dimensions. OrthoGen will stack the labels, turn the text sideways, offset the leader lines, whatever it has to do to ensure that the dimension text is legible. Now we can do more detailed dimensioning. I can bring up the style editor. I can go to equipment. I can tell it on the exterior labels that I want to do composite dimensions. And I've got grids and equipment turned on. It means equipment's going to be located in dimension string 1, grids in 2, and we can generate up to 3 dimension strings. So now we're going to put only dimensions on the outside. We're going to tag it on the inside. And we accept that and run that again. We should see a very different look. See, you've got now a single dimension string just to the equipment and 1 between the grids, and we moved our tags back to the inside. So lots of different styles we can apply using a combination of interior and exterior labeling. Okay, so before we leave equipment, I'd like to discuss the options, some of the options for labeling the nozzles on this drawing. Of course, we'll start with our style editor, bring up the style editor, pick the nozzle entity. Just tell them we want to label them interior, name, clear space. Also want and we're using the description for the label. That's the name of the nozzle tag in CADWorx equipment. They call it description. So we're going to, in addition to placing the labels on a drawing, we're going to have it generate a report in the drawing. And we've placed over here on the side a couple of blocks. One of them's name is N-bomb. The name of the block determines the entity report type, and the block marks the insert point for the report. So there's one up here called E-bomb right in this area here, N-bomb, and it allows you to position where you want the report. Now we don't try to draw the body of the report because it's so many options of what you're going to put in the order and so forth. Column headings are always different. So what you need to do is draw the frame of your report and put the bomb cell up at the top of it and let OrthoGen fill the report out for you. Alright, so we've made some settings for the nozzles to be annotated now. We're going to do them on the interior with clear space and go ahead and redo everything we have already. So we got equipment all located. Now we've got all the nozzle tags placed as well. And in addition, we've got a detailed nozzle report broken down by equipment item. The nozzle tag, the diameter, the rating, the end prep, and the elevation. So I hope using these basics of the interior labeling, exterior labeling, dimensions, coordinates, and so forth, you'll understand better how we do these as I continue on and demonstrate piping. Okay, up to now we've been doing everything interactively. We've just got a dummy style set here. We're just turning entities on and off and playing with some of the options. The real power is in these predefined styles. I'm going to switch to piping. First style up is one we call area piping A. We look at the pipe settings. It's using a method called longest, largest, or leaving. So this is going to work out using the diameter, the sequence code, and probably the fluid code. Determine each unique pipeline number within this drawing, and it's going to generate one label for every unique pipeline. This is mostly used in the process area. These drawings typically tend to be a little bit lighter. So with this predefined style, in addition to the pipes, we're also going to be tagging the instruments, and that's it, the equipment, the grids, and so forth. So we hit the update, re-annotate in longest, largest leaving mode. And again, this is the sequence number, the 704, 703. These numbers should not appear on the drawing twice. In addition to the equipment, you see now we're tagging our instruments as well. Instruments, as any inline instruments, we also support the CADWorx OrthoGen supplementals, and we will annotate them as instruments. So using our other styles, for example on pipe, if it was a pipe rack, we'd probably switch to direction changes. Direction changes, as it implies, is going to generate more labels. It's a style we would use in the pipe racks. We'll just update that. So you see we got more labels down here, and you will see duplicates because we're going to generate a label every time the pipe changes directions. Again, this is a specialty, sort of a specialty tagging method just for pipe rack drawings. Our other methods include only the pipes that do not leave the view, only the pipes that do leave the view, only the pipes that are normal to the screen for penetration drawings, and so forth. In addition, all these options on pipes apply to all routed objects. Includes pipe, tray, conduit, and duct. Okay, so that was a quick look at some of the piping commands and predefined styles. Before that, we were just working with an entity at a time, turning things on and off, and then we switched to this particular style, comprehensive style, where we try to do everything in one operation. Sometimes that's not possible, so we do give you an option, a command, that will allow you to permanently assign view styles to a viewport. The command name is Viewport Style, and once you enter that, you can list the styles assigned to a viewport, add a style to a viewport, or clear all styles. You select add, you select the viewport, accept it, and then you just navigate out to the style that you want to add. I'm going to add this exterior inner margin as a style, and permanently it's now attached to the viewport as X data. So if I update this now, even though it says area piping 1, you should see just in dimensions. This was exterior dimensions. That's the style where it only put the exterior dimensions. I can go back in now and add another style to this viewport. Select it again, and then select the next style there, exterior outer margin. Open that. Now we've got two styles assigned to this viewport, and if I update it, you should see the exterior inner margin, which is the dimensioning, and then exterior outer margin, where it adds the name labels outside of the dimensions. So we've added permanently assigned to the viewport the names of the view styles, multiple styles. You control the order that they're executed and so forth. Very powerful feature. This part of the presentation, I'd like to talk about using OrthoGen for fabrication drawings or orthographic spools. I'd like to show you how you can use OrthoGen and CADWorx to create these orthographic spool drawings. We'll be using the CADWorx isolate command to isolate a pipeline or segment of a pipeline, and the OrthoGen component dimensioning to add detailed dimensionings, and then the tagging all the components on the spool. We'll use the OrthoGen workflow of placing tags on the inside, and the dimensioning will actually follow along the piping. For spool drawings, IsoGen is the industry standard for piping isometrics and spools. IsoGen ISOs are sometimes considered almost free. They're not. They do require model integrity, and that's a good thing, being able to trust your model. The piping systems must be managed, and they ought to be broken down into segments with some sort of naming or stop signs, and in order to fit piping on a single drawing sheet where it is legible. IsoGen drawings are auto-composed. Long pipe run lengths are shortened on the ISO to make them fit on the sheet. This single line piping representation with skewed run lengths can be hard to interpret shop personnel, especially a local workforce somewhere in a remote area. Fabrication personnel sometimes have to receive specialized training in how to read these isometrics. This training, unfortunately, is usually lost before the next project comes along. It has to be redone. Fabrication mistakes can cost you exponentially in the rework and schedule delays. Certain piping configurations can be confusing coming out of IsoGen, and it takes additional training to learn how to interpret them correctly. In this case, it looks as if the pipe is turning up and then changing directions, when in fact this spool is all flat and there is no vertical turn. In this case and many other cases, orthographic spool drawings can solve this confusion. For this demonstration, we will start in model space. We've already used OrthoGen View Manager to click the general area where the pipeline we want to work with is. To create an ortho spool, you'll first have to isolate your pipeline by either putting it in a separate model or using the CADWorx isolate command. For this demo, we'll use the isolate command. Once the pipeline has been isolated, we can switch to a layout and use the View Manager to create our viewports and arrange them in the layout. We can also adjust the limits of a viewport to better fit our spool. Create a plan view, scale is 50, new viewport, drops it into the layout, arrange it on the sheet. Maybe we do an east as well, new viewport, arrange that on the sheet. I'm just going to zoom in a little bit and adjust these viewports to better fit around our spool. Next, I'm going to run the CADWorx 2D rep command on these viewports. get our piping symbology. Now we're going to use OrthoGen to add detailed dimensioning and tags to this viewport. We have 3 styles specifically for spool type drawings: component dimensioning styles. I'll pick the first one, component dimensioning basic mode. Select the update arrow, and the style is annotations are applied to the views. Using OrthoGen's component dimensioning mode, OrthoGen will follow the pipeline route, placing the dimensions. The offsets are controlled in the style editor. The objects to locate with dimensions are also controlled in the style editor. And in addition, we can place tags for the components. There are also 2 other styles specifically for spools. One locates dimensions all the pipes in the spool. The next locates the supports within the spool. So you can see there's options to add a lot of details. Come in and do the manual touch-up to the view. If the spool intersects a grid line, you can optionally also have it tied to the spool. So the last thing we want to cover is the configuration of the component dimensioning. We'll bring up the style editor, and since we're in this component dimension mode, we can define the entities that we want to include in our dimension string. In this case, we've got grids and supports. If we change that style to the component dimensions basic mode and look at our pipes configuration, we've got the grids being located in dimension string 2, the supports in 1, turns in 1, valves in 1, reducers in 1, and we could add the flanges. So you control how many dimension strings and which components will be located in which string. So I think you could see how these new tools at OrthoGen can help you speed up your detailing process, whether you're making spools or whether you're making traditional piping GAs with inline dimensioning. OrthoGen will give you a quick start on adding the details. Now I'd like to talk about OrthoGen for construction, concept we call on-demand GAs. Very powerful. You get a detailed model, you can define a volume, a looking direction, a scale, and instantly create viewports, compose them on the sheet, and then automatically annotate them. A lot of time and money is spent creating the 3D models. Isogen isometrics are sometimes considered free. Now using the OrthoGen View Manager, orthographic detail drawings can be practically free. Using OrthoGen View Manager, you can quickly create and manage the volumes used to create your viewports. Once you've clipped the volume, you can add annotations in model space or save the clip volume to a view as a viewport and annotate it there. This quick clipping and annotation allows for this on-demand detailed location drawings and detailed drawings for any volume of the model from any looking direction for any discipline. So I hope you can see that using OrthoGen with your CADWorx models, using its 3D model clipping, being able to annotate in 3D model space or 2D layouts, easily create viewports inside these complex models with your front-back clipping planes defined, instant piping GAs, equipment GAs to include with all work packages, 3D annotated installation details for pipe support location, rack intersections, expansion loops, vertical equipment, rack loading drawings, rack vent details, and more. Now I'd like to demonstrate using the OrthoGen View Manager to quickly define a volume and show its 3D annotation capabilities. To start the View Manager, we pick OrthoGen from the ribbon, select the Manage Views button, and the View Manager loads. Using this View Manager, we can define and create saved views volumes of the plant. These drawing view volumes are saved as clipped AutoCAD saved views. You can define a volume by keying in the high and low limits, coordinate limits, selecting the diagonal corners of the volume rectangle, or by creating these key plan views and selecting the volumes from them. Once you have defined a volume, you can name it and save it as an AutoCAD saved view. Just give it a name, hit the Save button, and that view is saved. You can recall these views at any time by looking at the Manage Views, AutoCAD Manage Views form. You see the new view, you can select it, see its clipping limits, select it and make it active. However you define your volumes, once it's defined, by selecting the Clip 3D, OrthoGen will apply the current clipping limits to your XREFs. Once you have clipped a volume, you can quickly define a looking direction, a scale, and create viewports of the clip volume in your active layout. To unclip the volume, select the Clear 3D button. Once the volume is clipped, since it's all pure AutoCAD, XREFs, X clipping, we could zoom in and we could use the AutoCAD 3D orbit command on the volume to rotate it around and review our design. OrthoGen's View Manager also allows for placing annotations in 3D model space. These annotations can be placed in 3 different modes and is controlled by the active Annotation Z setting on the OG form. But before we do this, I'm going to change the render mode to 2D wireframe to speed up the annotation. So now we'll bring the OrthoGen form back up. Our Annotation Z is set to 2D, which will tell it to draw on a layout. We're going to change it to draw in View High Z. That'll be the top plane of this clip volume that we're looking at here. Just use the standard piping style, hit the update. You'll notice all the center lines, the labels and everything are drawn in the top plane of this view. This mode of drawing in the View High Z plane is good if you want to plot this volume as a drawing. As you can see, our center lines are drawn in the top plane, so they're not hidden by the 3D geometry on the plot. The next method for placing annotations in 3D, Annotation Z setting of View Low, and as you can probably guess, it's going to draw all the annotation in the low Z plane of the view volume. The third mode for placing 3D annotations in model space with OrthoGen is called True Z, and as the name, you can probably guess what's going to happen. It's going to place the labels in the model and actually at the same Z as the objects they go with. Once annotated, change the mode to a shaded mode. You can zoom in a little bit. We can use the 3D orbit command, and you're able to rotate the model. You can see the line number labels attached to every pipe that's leaving or entering this volume. Gives you very good detail of what's going on in this area. Extremely powerful document to support field engineering. Now I'd like to show a few examples of what you can do with 3D annotation. The first up is 3D deliverables. These documents look like traditional 2D documents from the top view, but they also contain geometry that falls within that view volume. This allows you to rotate the drawing and use the clipping planes for detailed reviews. This is surely the best thing to ever happen to anyone who struggles to visualize 3D design from 2D documents. Now I'd like to show you some examples of 3D deliverables created using our annotation TrueZ option. Looking at this plan view, fairly detailed, annotated, all automated. Traditional drawing, you can use the zoom tool, zoom in, see more detail. You can use the rotate to rotate it up because it's not just 2D anymore. See our model geometry and our labels in true 3D space. Then we can turn on the clipping plane. Default is to clip in the Z. You can change it to clip in the X or the Y. You can flip the clipping direction if you want. And once you have positioned the looking direction that you want, use the rotate, maybe rotate it around a little bit more. Then you can use the step to step through the model to get to the details that you want to see. So it's a 2D, traditional 2D annotation document. This next example is a detailed view of a rack bent, showing all the support tags that go with this. From the top, again, it might be a little bit busy, but you use your rotate command, you tip it up. You can see that we've got tags for every support, for every pipe on this bent. Of course, we could have also added the dimensions between the support. This is the sort of details available to quickly create for your field engineering. This last example is a planning document created for this extremely complicated, very tall reactor. Now, looking at it from the top view, too cluttered to work with, but once we rotate it around, you can see that it's still very, very busy, but we've tagged every small equipment, every instrument, every nozzle, every support that goes with this model. Now, these label types are on a separate layer, so I can isolate and only look at the support labels if I wanted to. Turn on the cross-sectioning, you can see that we're able to quickly cross-section through this thing. We can use the cross-section properties page to adjust our clipping. We can step it up. You hit a point where you're interested in something, you can stop, you can rotate it around, have a look at it. I think you can see that this is a very powerful document, 3D PDF. Share with field engineers and such, study, dressing out this tower before they stand it up. Very powerful capabilities. All right, in summary, whether your project is front-end engineering, detailed design, whether you're just doing fabrication, installation, or construction, and you're doing it in the design office, the fabrication yard, construction site, OrthoGen can deliver detailed documentation from today's complex models. The picture you get from just using a model viewer may be worth 1,000 words, but in this industry, a picture without words can only communicate visual conditions where you need detailed identifications and locations. This is a very precise business. OrthoGen offers the 3 operating modes, each able to quickly create vital project documentation that clearly communicate your design intent, even from today's complex models. So this brings us to the end of my presentation. So I'd like to say thank you for your attention. There's my name again, is Joel Holmes. There's my email address. There's our company website name. If you have any questions or suggestions, or you'd like to do a WebEx demo or a trial version of OrthoGen, don't hesitate to contact us. Thank you again.
All right, thanks so much for that presentation, Joel. We do have a few questions if you've got a few minutes for us. The first one
Sure.
is it possible dimensioning in 2 languages, example as a primary language with secondary language in brackets?
I believe that is a possibility within your dimensioning style. I'm not an AutoCAD expert, but if the dimensioning style in AutoCAD can be configured to do it, then it should come out that way, yes.
Okay, and then is there a MicroStation V8i compatibility?
Not today with CADWorx models. MicroStation is pretty good with AutoCAD, so we could potentially bring the CADWorx models into the V8i OrthoGen world, but today, out of the box, we're not delivering anything MicroStation related with CADWorx.
Okay, and then the last question, can we get corrosion circuits in Ortho align with circuit BOM and testing info and TMLS?
Okay.
Do you want me to read that one more time?
Yeah. Circuit.
Okay. Can we get corrosion circuits in Ortho to align with circuit BOM and testing info and TMLs?
Corrosion. Yeah, I'm not much of a corrosion person.
Okay.
Can send me an example. I mean, if it's data in the CADWorx model, we should be able to tag it and locate it in some form or fashion. But I'm not real familiar with that. That sounds like a very detailed document.
Okay, and then there is one more question that snuck in. Is it possible to do a dimension skewed view?
Today it is not. We're
Okay.
purely in orthographic views. Good question.
Okay. All right, and that is all the questions that came in, and we are a little bit over time. Thank you so much, Joel, for sharing with us today, and thank you to the attendees for spending your time with us. Our time is up and our work is done. Everybody have a great day. Thank you.
Thank you. Thank you, everybody.